Alright, for our next video we're going to stick closer to the command line. Alright, so we're going to download a different molecule this time. So you'll need to type in, if you're following along, fetch, alright, and you do need an internet connection for this to work, of course, 3 FA and 0. Alright, now that should fetch you a molecule here. Now notice in this one, when we fetch it, there are all these plus signs around it, and this indicates water usually. Alright, there may be some other ligands in there, something that's sticking to the macromolecule here. So you can look around, see what's going on. Now, in this particular case, we're going to hide everything. I'm going to do that with the command line. So I'm going to go hide everything. Alright, and then I'm going to go show cartoon. Enter. Alright, now let's see what that did to our viewer. And this, of course, is what we're used to with our cartoon model. Now, I mentioned earlier that proteins are kind of classified into these subunits, these secondary structure units called alpha helices, beta sheets. So these are alpha helices here. We saw in the other protein that we were looking at, or I should say protein complex, more of the beta sheets that are like this. Sometimes it's a good idea, of course, to be able to visualize where these begin and end. And a good way to do that is to go back to our command line. And the way you do that is you would type in something along the lines of color, space, and I'm going to do red. Alright, so it's color, space, red, comma, space, and then you go SS and H for helices. So this is going to basically color our helices red. Now we can use the up arrow and it'll put in the exact same command last. If you're familiar with Linux command line, that's a common thing that has the ability. The up arrow and the down arrow let you move through your command history. So I have this here. I'm going to go back and I'm going to go color yellow, comma, SS space, S for sheets. H was for helices, S is for sheets, and now our beta sheets are yellow. So this is a good way to visualize things, keep them separate so you can see how this protein is organized. Right, so you see it's primarily, unlike the last protein that we looked at, the last one was primarily made out of beta sheets. This one is primarily made out of alpha helices. All right, so our next thing we're going to try here is let's go ahead and show our sticks. So I'm going to leave our cartoon on there, but I'm also going to show sticks. So now you can kind of see the side chains, the groups on the amino acids kind of stick out of the molecule. So this is kind of interesting. But where we had colored things, especially with the alpha helices and the beta sheets, they stayed yellow and red, if you notice that. Alright, so that's kind of indicating those are still. But we get to see some of the chemistry of the other things, see if those are odd or different in some way. So we're going to actually look at this, and we're going to pick out particular residues, particular amino acids that are of interest to us. In particular, I'm going to pick out residue 22, sorry. So it's going to say, first I'm going to hide all the sticks again. Hide sticks. Alright, makes them go away. So you see how to do that. But I'm going to show sticks. Alright, comma. And then you type RESI for residue, space, and then I'm going to go 22. And now only residue 22 shows up as a stick. So we get to see kind of the chemistry of just that one. That's the one we're interested in, so it intentionally sticks it out, makes it stand out a little bit more. So the other residue I'm interested in is, I'm going to use that up arrow on the keyboard to type the thing, but I'm going to change this time to 137, enter, and now I get a residue that's coming off of one of the alpha helices over here. And we're going to zoom in here and look at this particular one. So I'll use the third mouse button, or if you only have two, it's the second one. It's the left and right. It would be the right mouse button if you only have two, or the third one if you have three. So I'm going to zoom in here. I'm going to look at these. All right, I'm going to use the second one, move this direction, move it up a little maybe. Second one again, rotate it a little more, move it up. There we go. That looks pretty good. Now, at this point, we could do what we did before, and we could look at bond angles. So let's do that just for fun. I'm going to shrink this down, and I'm going to go to Wizard, Measurement, and I'm sorry, let's do distances. Okay, so make sure we've got that set as distances, and we can click here and here, and see that that's 2.8. Click here and here, and see that that's 2.9. All right, those are just some of the interesting things we can do here. And now I'm going to delete all measurements, and I'm going to hide everything. So to hide everything, I could use the GUI and go up here, but instead I'm going to do it here. I'm going to go hide everything. All right, so it goes blank. Then I'm going to do something new that we haven't seen. I'm going to go show surface. Now surface is a little different. Basically, these are the interaction areas. Without becoming a chemist here, I'm certainly not a chemist, so this is not my forte, but this does kind of give us a kind of a unique look at what the surface of this protein might look, the interactive surface of this protein might look like. Alright, so sometimes this is useful. Now it goes out on you if the image fades a little, use that middle mouse button, move it over a little so that it's in the range so that you don't get that happening much. Here we can move it. I still get a little of that. But as you can see, when these two, by the way, this was an interesting one. It has a hole in the middle of it, doesn't it? Kind of interesting. All right. So moving that around, you get to see some of the interaction and where those alpha helices are. Remember, the alpha helices are the red parts, and they form that part of the structure. All right, and the yellow are the beta sheets. All right, so we're now going to do something different. Let's go back to the command line, and I'm going to go color gray, Gray. All right, enter, and so the whole thing goes gray now. All right, and then I'm going to go, and then we can redo this color space red, comma, SS space H again, and this would show us kind of just where the alpha helices are. You could do the same thing with the beta sheets. Alright, right there. Okay, that's giving you kind of an idea. You can do some other things. There's something called transparency. Set transparency, comma, space, All right, and let's do that at 0.5. It kind of dims it. Might help with the viewing of it, so you can see kind of the parts that stand out a little better. You can now go back to show sticks, comma, and we'll do it with certain residues. So let's do residue, and then we can do several at a time. Let's try these. Plus 99 plus 121. Do that. So there we show certain residues that we might be interested in and where they are in relation to it. Are they on the inside or the outside at any given time? When we rotate this around, where are they in our inside here and what they're doing? Could be useful if you're interested in knowing about what's going on inside the molecule as you rotate it and from what direction you want to see how these are orienting themselves, these side chains for these residues. All right, now another thing you might want to do is show spheres. This is a little different also. So I'm going to go show spheres, all right, and comma residue 208. All right, and now basically you're seeing, instead of the side chain, you're kind of seeing it as a sphere. Where is that particular residue? Might be a slightly better, depending on what you're doing. Maybe you want to distinguish this from these side chains. Maybe see when it comes near those, you would rather see it as a sphere. An interesting thing to do. Now I'm going to fetch another molecule. We haven't put two molecules on the screen together before. So this time I'm going to fetch 148L. All right, and so we now have another molecule on the system as well. Now here, this one, we're going to hide everything, show cartoon. All right, so this one is over here. Now we could do the same as we did before. Why don't we use the up arrow and do show surface. All right, and now that's different. We've kind of got everything set, but you can see the surface on top of the cartoon. Just a little bit different way of viewing it, just depends on your interests. Now if you want to kind of move these around, I can move them. So they do move together, all right, at this point. You can separate them and orient them so that they move differently. All right. Now the other command that you might want to do is to align them. All right, so let's try that. Let's see how that would work. Align. Right, and it's 3 FA 0, all right, comma 148L. All right, now what did that do? Well, let's center this. It kind of sticks them on top of one another. This could be interesting if you think these are related and you want to see if maybe they line up in one particular way. And actually these do pretty well. All right. So let's do a hide everything. Oops. Hide everything but I only want to hide the one molecule, and that's the 148L. Alright, and let's see, go back and see what that looks like. And we're back to our molecule here. Now, if we want to color, say, blue, the 148L, color blue, comma, 148L. Know that did anything. Try that one again. I put 149. There we go. Let's see. What did that do? You still don't see any of it. The other one is covering it up. Let me see here. Now you can use this to tell you what was going on. For instance, when I typed this in incorrectly, it said invalid selection name 149L. We're interested in 148L. So it colored them blue, but we didn't see anything. Let's try show 148L. Now that was an unknown representation. These are our choices. So let's do, let's go back to show spheres, comma, all right, 148L. There we now see the 148L as spheres around our other molecule. And a little interesting. Not sure what you can gain by this, but it does show you that there are lots of possibilities for visualizing these molecules with the tools that you have here. All right, and that's it for this video.